Welcome tonight for the already 41st meetup in Switzerland. I remember when Nicolas organized the very first meetups, I was an occasional visitor, but the last 2 years was no longer that easily possible because now, since I started to work for Elasticsearch, I'm Daniel. I'm working for Elasticsearch as a trainer instructor, so that means I'm in Switzerland, but most of the time I'm out in the field teaching somewhere. And so it's with great pleasure that we could make it happen, that now I have the chance also not to just attend a meetup in Zurich, but also to present. And the topic I've chosen to talk about is about relevance. So whoever is interested in full text search, so as soon as you're interested in full text search, relevance becomes a topic. So you want to make a good search experience, and a good search experience is if users find what they're searching for. Maybe not on page 999, but ideally on the first page. And the big question is, well, how can you measure the quality of your search application? And this is also what Lord Kelvin once quoted, like, if you cannot measure, how can you improve? Because search, as often, it's not just a project, it's kind of a part of a strategy, part of a mission. So it's steady improvement, but how can you improve if you cannot measure what you currently have? And I would like to start this talk with a quick survey. So I ask in the round, who has an application in place that relies on full text search or is using full text search? Oh, nice. You? Okay, so quite a bunch. And who is about to develop an application that relies on full text search? Yeah. Last time you spoke about logging, right? So now it's full text search. Great. And who has one who is already in production? Live. Oh, so many. And now how many hands stay up when I ask who has some kind of measure to to identify or measure the quality of your search experience? It's getting fewer, right? And okay, so I guess some hands are missing. Why are they missing? Is it maybe that you have something in production like this? Well, before I joined Elastic, I did search projects, and that was often a topic. Don't touch it. We might break it. So, okay, but the talk is about ranking evaluation. So it has to do with relevance. It has to do with measuring relevance. And what we ideally would like to get is to have a repeatable way to quickly measure the quality of a search results. And yes, over a wide range of user needs, because obviously you not just have to deal with one single query. Users might look for different kind of information. And what are the keywords in that approach? What we would like to get? Repeatability is one keyword. So ideally, we want to have something that allows us to automate the process. So don't just make people sitting at the screens and look like a thumbs up, thumbs down. I think it's good. I think it's better. And I think most of the time this is how it works. It's just God's feeling. You have kind of you roll out the new solution, and then it's just a question of time until you have the department leader in your office and says, hey, your search is crap. My search result is no longer at the top. Fix it. But what means fix? So we want to have something repeatable. We want to have something that also allows us to quickly measure, not just conduct long A/B testing studies. And, well, how do we judge the quality? Ideally, just looking at the number. That's the easiest. So a numeric output would be great to define the quality. And, well, what do we actually measure? What are the user needs? And when I used to work for commercial search engine vendors, there was one slide which I really liked, which was about what is search about? It's matching intent with content. That's the whole story. So a user, whether it's business or a private user, has an intention, has an information need. On the other hand, you have the content. Make that match. And of course, you have to be aware of the user needs. What is the information your user is looking for? And model them or make your solution addressing those needs. So these are the 4 goals. And, well, this is also what it takes to get started then when you think about evaluating your ranking solution. So you need to start with getting a good picture, good idea. What are the information needs of your users that you would like to address? And then, obviously, also should have a good overview over the documents, the content that you provide to your users, and ideally rate all your documents. I know that's a big topic, and I've never come across a solution where actually customers had such a so-called golden universe where they really knew what's supposed to match for what query. But that's part of the preparation. You have at least to have a subset, if not full labeling is possible, so to choose a subset of your documents that match or should be returned along with a specific user need. And then in the end, also choose a metric that you want to use in order to calculate the relevance. So where do we position this ranking evaluation API? There are two dimensions, so some tools or some approaches are rather fast, some are rather slow, and on the other hand, some approaches take more or less preparation time. So obviously you can start by just looking at the screen, which is not so repeatable and it doesn't really scale, it's not automatable, but it requires hard to know preparation time. On the other extreme, you have the user studies, probably very expensive, a lot of preparation time, also difficult to automate, slow, and you have various other things in between. Ranking evaluation, definitely it requires you to have some preparation time, so you can't get anywhere far without doing your work up front. But once done, that allows you to really measure the quality of your search solution pretty efficiently, at a fast speed. Good. So, but once you have a clear idea what you want to achieve, you have an overview of your content, and we will learn about this rank evaluation API. Once you make use of that, what can it do for you? Actually, it can help you at multiple stages during development or during the life cycle of your application. First, it can support you at development time. So it helps you really to learn, are you making progress or are you actually doing harm to your solution? Does quality get better or does it get worse? Then the slide I presented at the introduction, don't touch, chaos, danger. Once you're in production, it's difficult to change something. Do you know, how can you predict? Do you break something? Will relevancy go down? Maybe you fix one thing, but at the same time you break 99 other things. So the rank evaluation API can also help you with respect to feeling safe when you want to do changes or monitor changes in production. And I think what's underestimated, but looking back at my project experience, a really good benefit of the rank evaluation API is also to serve as a communication tool. Because you have to do some preparation work, which means identify information needs, identify metrics, and then you build your solution, and then you see how well it performs. And then later on, if you have some nice or not so nice conversations with some other stakeholders who say, oh, your search solution is crap, basically you can go back to the requirements, say, look, this is what we model, and in case something was missing, let's add that to the topics. Let's add that or include that as part of the ranking evaluation, similar to like unit tests. Probably you don't start with a 100% coverage of unit tests, but once you learn that you have a gap, you fix it. Good. So what can help us getting there? It's the rank evaluation API. And it's a fairly new thing. It just got introduced in release 6.2 of Elasticsearch. It was co-developed between Christoph Bücher and Isabelle Drosch. They also, or especially Christoph, get the credits for the presentation. I didn't create it on my own. I'm just using his presentation and his demo. And it's still declared as experimental. That says, well, it's not yet production ready, meaning that we truly believe that it's a good thing to have, a good starting point, but things might change. We also learn our lessons, we get feedback, so that's why it doesn't have the same quality as production code, so APIs might change. And what does it require? It requires a set of search requests. So you have to have an idea what will be the queries you send against or to Elasticsearch, and this is basically what models our information needs. Then what you also need to have is a set of document ratings. We said that you have to have a small subset at least of documents where you know about the quality. For one information need, is that particular content relevant or is it not so relevant? And then you need to define on which metric you want to use. Currently, the rank evaluation API supports 4 different metrics. So using the API basically requires 4 building blocks. One building block is the requests, where you formulate your search queries. You give them a name, you provide the queries, you provide also the ratings. The ratings basically is a list of all the documents. You identify the documents with their ID along with the rating. And in the end, you also define a metric. Here we choose the metric precision at K. I will explain the metrics in a bit. And what you get back is a response. And the nice thing, at the top, very top of the response, you get back a numeric information. Similar to a score, the metric score, and that's the indicator how well your relevance is doing compared to the tagged or labeled documents and the modeled information needs. And then for every single query, you get a score for that particular query, which models one information need. So the overall score, the details per query, per information need. Also, you get back individual hits, but you also get back hits that maybe made it in, but you didn't label them. So that might be a good opportunity to also label these documents. So you know, okay, we have this document with ID 1960795, and then you use this opportunity to judge, to identify, is that particular document relevant for this information need? The information need here, well, it's my query ID 1, so it's a little bit abstract. We'll see in a bit how that really looks like. And then the metric, here we chosen precision at K. I will talk about the metrics in a bit. So the big question is, how do you get started? Because it's quite a massive task to label the documents or to rate your content. But why not start small? I mean, you start modeling a couple of use cases, information needs, you label some of your content, and once you get started, maybe initially you have to do everything on your own, but maybe over time you can also ask the community to help or others in the department in your organization. And we'll have a demo about this rank evaluation API, and there we'll also learn how Wikipedia is doing the same thing. And very important, don't forget, it's not like a project, once done, once completed. It's an iterative process. So what are the metrics available? There are some very straightforward, simple metrics, precision at K or reciprocal rank. Basically, this is a number. In the case of precision at K, we simply count, okay, we returned how many search results, maybe 10 search results, maybe that's what we are interested in, first page, and we simply count how many of the first 10 results are relevant. Is it 1? Is it 3? Is it all of them? Reciprocal rank, here we don't care how many search results are relevant, simply what's the position of the very first relevant result. So these are binary metrics, very simple to understand, but they also don't model the whole world. We have the more advanced metrics, discounted cumulative gain or expected reciprocal rank, a more advanced one. But let's have a quick look at the individual metrics. The easiest to start with, and the one I'm also going to use in the demo, is precision at K. So normally when talking about relevance, you have these two criteria, recall or precision. So it's all about precision. Your first 10 results, your 100 results, your 1 million results, how many of them are good results and how many of them are false positives. But in the end, we don't really care about the 900th or 50th result maybe. What we do care is at the first 10 or first 20 results. That's why precision at K. So K represents what is the first page or it's the group you're looking at of the hits. And then you simply count 1, 2, 3, 4, 5. Ideally, K documents are relevant out of K documents. So it's very easy to calculate. It's easy to understand, easy to communicate. but it's also extremely unstable. So different information needs new content. Things can change quite rapidly. And another disadvantage of this, we don't care at all. Maybe you have half of the results are relevant, but they all occur at the end of page 1. Whereas the second metric, reciprocal rank, okay, here we do care. Where do we get the first relevant result? Is it ideally at position 1? Cool, great. Then it would be 1. If it's at position 10, then it's 0.1. But in the end, the disadvantage of this one is we don't care how many results are relevant, just the position of the first relevant one. And this is where the more advanced metrics are a little bit more, as it says, advanced, like the discounted cumulative game. Here we look basically at all the results and simply count up the relevance score, or we even weight it, so take into consideration the position of a document. So if it pops up at the first position, a relevant one, then that obviously should have more weight as compared when it pops up at the 10th position. And you can also normalize that. So I don't want to make that an expert talk for relevancy. So that's why also on the fourth metric, expected reciprocal rank, there's not too much I want to say about that. So if you're really interested in information retrieval, you can read into that. But just to introduce you to the 4 metrics the rank evaluation API currently supports. Good. And now, as you've heard about the goal, the idea, and the whole concept behind the API, it's demo time. It's a good opportunity to also demonstrate the API. And what we prepared for this demo, basically, we use some content, a subset of about 1,800 documents from English Wikipedia. And Wikipedia is really a nice content source because we can not just download the content, but we can also download the ratings of the individual pages, because the Wikipedia Foundation is doing the very same thing as we implemented here with the rank evaluation API. Basically, they label their documents whether they are relevant or not in order to measure whether they break something with their search or whether they are on a good track. And the whole demo, that's a reference in this presentation. So whatever I'm presenting here, you can download the GitHub repo from my colleague Christoph, and you can basically redo this demo in your local environment. Good. With this, let's switch to the next screen. And Nicola, do I need to do something? It will record the whole screen? Yeah. Okay, good. Okay, so for this rank evaluation API, there's also a blog post written by Christoph Bücher that also goes through the whole demo data. I can share the link as well. That's the repository that contains all the data. But now let's start with the data he's using. So we were talking about Wikipedia. Well, Wikipedia allows you to download the content, so you can download the whole slice of the data, nice as a zip file. But in parallel, they also have this, I think it's difficult to pronounce, at least for me, the Discernatron project, which is a tool that allows participants to judge the relevance of search results. So this is a project from Wikipedia. You can create an account, log in. So I did that here for you. I'm logging in. You can get a briefing, some instructions how to use this tool. And basically what Wikipedia is inviting us to do is, well, they present us an information need, a query, and they ask us to rate some Wikipedia pages. Rate them as unrated or irrelevant. Irrelevant would be value 0, maybe relevant, maybe a rank of 1, probably relevant, number of 2 or score of 2, relevant, score of 3. So this is what Wikipedia is asking us to do. And the way it looks, the way it feels, once you get started, you get suggested like a query. The query or the information need is something like law in London. And then they present individual Wikipedia pages. And you can say, well, Jude Law in London. Okay, that's more about an actor. Maybe that's irrelevant. What about the other? The Magic Circle, law firm, London. no idea, maybe relevant. City of London Corporation, maybe that's again irrelevant. So I think you got the point. So maybe initially that would be a bit overkill, a bit too advanced to come up with something like that. So maybe you start on your own, labeling documents or a subset of the documents by yourself or a small team. But over time or to scale, you could also think of implementing something like that, asking other coworkers or your users or the community to provide feedback. And what Wikipedia is doing, basically, they also provide then the results, the information, the ratings. So here we see an example. We see the information need JFK. So a query, someone searching for JFK. What do they expect in English Wikipedia? Probably they expect the Wikipedia page about John F. Kennedy. And we see for this particular page we have 6 scores, 6 ratings, and actually the score is 3, so the maximum. That's probably what most users would expect as the most relevant page. So this is the source, the input, also the data we indexed or we used in our demo. So now we switch to Elasticsearch. We've indexed everything, a subset of 1,800 documents, and now we simply can start searching. So a very first query, a general query, I simply execute a query, searching in an aggregate field. So the all field is one we constructed here, where we basically put all the content, whether it's in title or in description or author, we put it in this all field, and we search in this all field for JFK. And for better readability, we only render the title of the Wikipedia pages, and we can see that some matches are about some airports. Again, an airport, a hotel, air train. Okay, but where is John F. Kennedy? So maybe the quality is not so ideal. So we could start trying to improve it. What if? What if we just search in title? Does it get better? Well, it looks a little bit better. We get the film on the top. We get the disambiguation page at 4th position. What if we would search in the text? Well, JFK International Airport ranks 2nd, but John F. Kennedy himself is gone. So yeah, but you can get a feeling. That's probably how some of you might do it, or some developers might approach it, just by playing a little bit around this guts feeling and then personal judge, is it getting better or worse? So maybe this is not so scalable, automatable. So that's maybe okay as a starting point, but not where you want to end with. Then let's assume we are a little bit more advanced as a developer. We already learned that maybe we should use a different query. Maybe a multi-match query is better, that we search across multiple fields in parallel. Let's simply execute that query. So now we search in the title field, in the opening text field, and some other title-related field for JFK. And that seems to look already much better. We get the Wikipedia page for disambiguation. So when there are multiple pages that talk about the same concept or same term, Wikipedia has these pages. Do you mean the president? Do you mean the airport? So that definitely looks better. And John F. Kennedy ranks 3rd. But still, that doesn't help us much. I mean, now we know that this seems to be a better query, but beyond that, it's still try and error. Now, why not using now the rank evaluation API? So this is what we see on the left. The endpoint is we use our index name and simply call the _rank evaluation API. And we need to formulate a couple of requests. Now we start with one single request. We give our request an ID. This is our JFK information need, JFK user need. So just our query searching for JFK. And if you look at the query itself, query, multi-match, best fields, this is the same query as before. We just wrap this query now, put it in a request, and the request is a core element or core part of the rank evaluation API. So I specify what I would like to get rendered. I would only want to see the title field. And now I have also the Wikipedia information about the ratings. So for instance, the page with ID 305 something has a rating of 1, which says maybe relevant. Another page has a rating of 3, which says that's absolutely relevant. Another page has a rating of 1, again, maybe relevant, not relevant at all. So this is what goes hand in hand with our user requests. So the request made up of the query and the ratings. And then the third part of our rank evaluation request is the metric. Which is the metric you're going to use? We use an easy one, easy to understand, precision at K. So we are only interested in the first 5 hits. And out of the first 5 hits, we consider all the hits to be relevant that have a rating of 2 or more. So if it's maybe relevant or probably relevant or relevant, 2 is probably relevant and 3 is relevant. So we only count those hits. So same query, just along with the ratings and the metric, we execute this query. And we get back the same results as before. We have the disambiguation page that comes first. We have John F. Kennedy, the page we probably would like to have, comes third. So the same results as before. But in addition to that, we get a metric score, 0.6. That's the result of the rank evaluation API. Okay, 60%. What does it mean? It means this number gets calculated across all our information needs or user needs that we modeled. We only provided one request, so 0.6 is the same as 0.6 here. So this is basically the score, how well our JFK query is doing. And furthermore, what does 0.6 mean? It's based on this metric. It simply tells us that out of the 5 results that we got back, out of the 5 hits that we got back, 3 of them had a rating of 2 or 3. So were considered relevant. And what we also see that in our 5 hits, we had a document that made it in that we didn't have a rating for. So that would be a good opportunity to also rate this document. Okie doke. So now we have a good starting point. We still have the same query, but along with the query, we also have some numbers. And why not starting modifying it? So now we can say, okay, but we have additional fields. We also have an auxiliary text field. What if I search also, in addition to the 3 fields, also in this particular field? I add this field to the query. Oh, okay. It doesn't take a lot of guts feeling. I see that immediately the score goes down. So it seems to get worse. What if I include the text field? Okay, a bit better, but maybe it was best the way we had it originally. So because that resulted in like 0.6. But so far we only modeled one information need. But as we have everything in place, it's now very easy to go to take the next step. So maybe we learned that there could be queries that do a better job with respect to relevancy. Maybe it helps if we include popularity. So something similar to Google, like PageRank, but here we simply count the click rate. And because of that, we basically changed our query. We converted it into a function score query. So we have still the same query in here, but for relevance, we multiply the score from the query with a so-called popularity score. So some information we've stored somewhere, whether it's click rate, etc., we just think that might be useful to include that part in our query. And now we can measure what's the impact of this change. We used to have 0.6. Now we have 0.8. So with respect to JFK, this seems to do a good job. But still, we modeled only one information need. And it's very unlikely that all your users search for JFK. So what we could do is, okay, let's pimp it a little bit up. Put our whole query in a so-called template, search template. So here it's the same query syntax. We have our function score query, the multi-match request, best fields type across these 3 fields. We didn't change anything here. We have our function score, popularity score that we take into consideration as well. And our requests use now this search template. So we still have our JFK query, which is using our template. And the only thing we need is to provide the parameter, because the only different thing across all our information needs is now the search string. Some are using for JFK, some are searching for the Great Beer Flood query. So that was a happening like 200 years ago in London, where a beer brewery, kind of a tank, exploded and 8 people got killed and the buildings got destroyed. So there's a wiki page about that. Let's see how well our data is doing, or our query is doing for this. And the third query, naval flags query. So now we have the same query as before, but we model 3 information needs along with the ratings. And what we see now is that our JFK query still ranks the same as before, 0.8. So great job, excellent. What about our other information needs? Naval flags query, 0. Oh, maybe not so ideal. And what about the Great Beer Flood query? 0. So we can see that we did a pretty good job for one information need, but pretty useless for the other information needs. But now we can easily start tuning it. So what if popularity did a really good job to the JFK query, but maybe that was a little bit too much for the other needs. So why not just adding up the scores? So popularity, we add the score up together with the normal score from the query. How does that look like? Okay, overall score increased. JFK query is doing a little bit worse now, but the naval flags query is doing a pretty good job, and the Great Beer Flood also got some hits back at least. Then we can simply start playing around. What if we weight the function score a bit, that we say, well, we not simply add a value of 1, we modify, we tune that value, and then we say, okay, actually that seemed to have done a good job again. So the metric score, the overall score goes up. JFK query performs great as before. Naval flags query also performs decently. Well, the Great Beer Flood query, still not that ideal. But I think you got an idea how to use the rank evaluation API, because now you're pretty confident. You have something to compare against. You can tune your query, you can change your query. Maybe you think that this logarithm was maybe not so ideal. Maybe I use the other function here, the log for 2p. Does that do a better job? No, it goes down again, so let's keep it. But what if I add additional fields now? Does that do a better job? Does that help my query? And you see it also goes down. So basically with the rank evaluation API, we get what we were expecting for. So it allows us to very quickly learn how we are doing by simply outputting a metric. It's fast. We just change our query. We learn the metric. We can repeat it, we can automate it, and we can use that also as an explanation tool, communication tool towards our stakeholders and also during our development phase. So with this, I conclude the demo. I mean, obviously there are some in the GitHub repository download, there are some other demo scripts. You can also change the metric, the rank evaluation metric that you use to calculate the quality. But besides this, I think you got a good idea what this API is about. And for us internally at Elastic, this is simply a starting point, because of course now you can think of many other things built on top of that API. What if we can combine that with some kind of automation, play different scenarios, make use of this query, make use of that query? Are we progressing? Are we decreasing the quality? But that's just a very first starting point to have something measurable, repeatable, and fast. Okay, can I open for questions? Dead silence. Maybe that helps. Yes, please.
Is it possible to rate, for example, to say the Great Beer Flood is important, but not that important as another beer so that the metric score in overall, it says, okay, the first beer query has a high rating, but the other one much lower.
So if I understand you correctly, you're talking about giving weights to the information needs,
Yes.
not to the documents, not to the content, but to the information needs.
Exactly, to then have the overall metric score based on that.
So here the API, at the moment the API does not consider that or offer these capabilities. So you formulate your user needs, but they are all equally rated, and everything else needs to be done on the rating side and on the content. But maybe I take that up also to ask the creators. Yeah. Other questions? Yes.
Assuming I have my website and I, for example, allow users to get the relevant
Yes.
results, is there a way to somehow like incorporate this rating of users in prioritizing search results?
Well, this is something similar that we saw here when we said we introduce so this has less to do with the rank evaluation API. This has more to do with what is the query you're using or how do you calculate the score. And here, as an example, we used our query, and when we calculate the score, actually, we made use of another value that was stored in the popularity score, and that could be a field that you update along with your content. This is not out of the box or connected. This would be something with Elasticsearch tools. You can basically leverage that additional information and incorporate that, make it available, and then use it as part of your query or score calculation. There was another or two other questions. Yeah.
What happens if you keep adding the documents to your reference index and your relevance just starts decreasing, and you find out that this kind of query simply doesn't work for all kinds of searches you have to make?
I really like that question. I really like that question because when I did search projects, now I'm even using that term, search project, I said it's not a project because this is typically what happens. So when you take it as a project and what you developed is not usable, then no one cares. But let's assume what you developed was great, excellent. Everybody wants to use it. So they use it. They come up with new queries. It's less ideal. They come up with additional content. And well, the more content you get, that will have an impact. And normally, search quality decreases if you don't do anything with it. So that's why it helps. We can't solve that problem for you, but that's why it helps to have something like that to steadily monitor. You add new content. You see, are we still performing good? Or does our quality decrease? Is there a need for action? Are there new documents that are now more relevant? Or is there just a lot of noise that we need to tune our queries? Yeah, the problem is there, and you need to solve it. I think I often get a question like using AI also in the context of search. I said, well, you could think of different options, but at the moment, I think we focus on what we have under control. So we also leverage machine learning, but for some dedicated use cases. And at the moment, that's more for anomaly detection to do predictions. But yeah, who knows in the future? That's one starting point. And if we figure out something reasonable that we could do with all the building blocks, but that's probably not something that's going to happen tomorrow. Yeah. 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 I'm not sure that I fully understood the question. So it's about the two documents that are related, or multiple documents that are related? The information need is expressed in a query, right here. Mm-hmm.
But we have the need when we provide documents, we want to get the real documents.
If I understand that from Elasticsearch point of view, so if you want to looking for the related document, you look at like more or less this query, right? What you need, right? And you can consider that the whole document, original document is one query. That looks like more or less this query.
That would be, of course, here the main focus was on introducing the rank evaluation API, which helps you to come up with some idea number to measure the relevancy. But this topic was not about exploring all the available queries. And of course, there are many more queries than the match queries, whether it can get as complex as you want with respect to scoring. It can get more complex into modeling and more like this if it's about, I'm not quite sure. Or maybe we can take it up after the talk. Yeah? Oops, there were some. Yeah?
Practical numbers to get use out of this. I mean, here we have, I think, 2 information or 3 information requests and 100 rated documents. But this is certainly not going to help me in a real life scenario. Do I need 10% of the do I need 10% of the documents, 50%, 5%? What are your experiences there to make it really useful?
So experience with the rank evaluation API, that's a new API. So with experience with this specific API, I can share a lot. This is development driven and we just presented. But experience from doing projects, yeah, you would say in an ideal world, I have everything modeled, but you know at the same time this is impossible. So the only thing I know, it seems to be practical because what Wikipedia is doing, they do actually something like that. And you see that they ask users to rate and qualify and judge. And if I tried to map that to projects I did, to some financial institutions here in Switzerland, they had some requirements were simply impossible because they said like, oh, if a user is searching for this, I want to have the product page at the top. And then I asked this client, product page, how do you know that one web page is about a product? Oh, we don't have that information. Okay, then we cannot help. So we cannot solve things where the information is not there. But assuming that you know that these are the more important pages or these are about your products, then I would start focusing on just the most important needs. And the starting point could be that you get the requirements from your stakeholders. Another starting point could be you have an existing tool in place with some analytics on it, so that you go through the logs. What are the most frequent queries, or what are the most frequent queries that result in 0 hits, the other end of the long tail. So, but I cannot give a general guideline. I think it also depends really on your content. Oof. There was first one behind, and then you, yeah.
So in practice, when, for example, we have a web page with the Zurich CH web page,
Yeah.
and people are searching, and I understood, okay, tweaking the algorithms would be one thing to improve the search experience, but could we also give the business the possibility to better label pages so that this improves the search experience, so that it's more driven from the business side to change that, so and is supported by the tool, where for at least evaluation of the most common terms, people were searching what are the results then, and they can play around a little bit with it. So is that
I think that goes again, that's a general topic about relevance and queries and less about this API. But you could, I mean, previously we implemented solutions like that we had a field in our search index, which was like similar to search engine optimization, SEO, just like search keywords. And that field was populated directly by the end users using your solution. So this is how we implemented it. I mean, not Elastic, but when with projects with clients before, if you want to expose such a thing. But with metadata, it always is how good is the quality of your metadata or this tagging. Then you have the similar races like with Google search, right? And then you add these keywords. I want to rank it like this. I want to make it to the top. The only thing in businesses, in enterprises, where metadata quality is really good is with expense reports. But there it works because every employee has an interest and motivation, but otherwise. But we implemented or previously I implemented features like that, yeah, to expose it and incorporate that in the query. It's not part of the rank evaluation API, it's part of the query. But that also implies having something like the rank evaluation API, a solution based on that, is then more important because your content, your relevant, I mean, then you include that field. Basically, here you would have an additional field, probably something like search keywords. So you would also search in that field, and maybe because that's a very important field that you want to weight higher, maybe you want to even give it a boost or something like that. So having said so, that can have a significant impact on your query. And then you want to regularly monitor what's the impact as my content changed, because that would be part of the content. That makes sense? Yes, no? Somehow. So let's, maybe it works with a beer. Or to the next. Yeah, sure. And sorry, I will also get to you. That's right. Okay, thank you. Good.